Hello everyone. Today we will discuss Laplace transform of some more elementary function. Next, seventh one is Laplace transform of t raised to n. We have to find what is the Laplace transform of t raised to n. When we apply basic definition of Laplace, we get L of t raised to n is equal to integration from 0 to infinity e raised to minus st into t raised to n into dt. Here we are not using Bernoulli's rule. See here, when we use Bernoulli's rule, e raised to minus st is integrating part and t raised to n is a differentiating part. See, t raised to n, when we differentiate this one, we get n into n minus 1. When we again differentiating this one, we get n into n minus 1 into t raised to n minus 2. Like that we have so many terms, but we must have any constant term. To get differentiation of that one is 0. But here we will not get any constant term. So we will go to another method. First we have to put st is equal to x, then when xt is equal to x, we get, when we differentiate this one, we get s into dt is equal to dx, which implies dt is equal to dx divided by s, and here x varies from 0 to infinity. Here x is varies from 0 to infinity. When we change my st by x and when we differentiate this one, we get s dt is equal to dx ds by s. This integral changes to integration from 0 to infinity e raised to minus x into t raised to t is here t raised to n, but st is equal to x, we get t is equal to x by s. Therefore t becomes s by x raised to n and dt will be ds by s. Therefore Laplace transform of t raised to n will be this one, integration from 0 to infinity e raised to minus x into t is x by s raised to n dx divided by s. Here it is x means it is dx, not ds. This is dx and this is also dx. Here 1 by s raised to n and 1 by s is constant. Take outside 1 by s raised to n plus 1 by s raised to n into 1 by s. It will be 1 divided by s raised to n plus 1. Remaining is integration from 0 to infinity e raised to minus x into x raised to n into dx. Laplace transform of t raised to n will be 1 divided by s raised to n plus 1 into integration from 0 to infinity e raised to minus x into x raised to n into dx. Here to solve this integration, we have to recall the gamma functions here. See the definition. Using this definition of gamma function, we can easily solve this integral. Gamma function definition is, gamma function is denoted by gamma n, where n is greater than 0 and is defined by a definite integral, which is gamma n is equal to integration from 0 to infinity e raised to minus x into x raised to n minus 1 dx, where n is greater than 0. Here integration from 0 to infinity e raised to minus x raised to n minus 1 into dx, but our integral is here integration from 0 to infinity e raised to minus x into x raised to n into dx. Here we have some properties, that is gamma of 1 is equal to 1 and gamma of n plus 1 is equal to n into gamma n, which is equal to n factorial. Third one is gamma of n plus 1 is equal to integration from 0 to infinity e raised to minus x into x raised to n into dx. See this property, this integral is same as this one. Here we have in our example integration from 0 to infinity e raised to minus x into x raised to n into dx, which is equal to, from the gamma function properties, gamma of n plus 1. Here we use result of this integral is gamma of n plus 1. On using that property of gamma function, we get 1 divided by s raised to n plus 1 into gamma of n plus 1, which is equal to gamma of n plus 1 divided by s raised to n plus 1 Laplace transform of t raised to n. Therefore, the Laplace transform of t raised to n is gamma of n plus 1 divided by s raised to n plus 1. This is the final result here, where n is a constant. Here n is constant. Next we have note here. First point, we know that gamma of n plus 1 exists if n is a positive real number or n is a non-negative integer. Means gamma of n plus 1 exists only when n is any positive number. Hence the expression for Laplace transform of t raised to n is valid for n belonging to these categories of n. Meaning is Laplace transform of t raised to n is valid only when the n belongs to any positive real number. Next point, here we know that gamma of n plus 1 is equal to n factorial. This is from properties of gamma function, that is gamma of n plus 1 is equal to n factorial if n is a positive integer. When gamma of n plus 1 is equal to n factorial, Laplace transform of t raised to n is equal to n factorial divided by s raised to n plus 1 if n is a positive integer. Here Laplace transform of t raised to n will be n factorial divided by s raised to n plus 1. This is also one of the most important result which you have to remember. So here we shall establish above result, means this result without involving the gamma functions. We shall establish the above result without involvement of gamma function, that is Laplace transform of t raised to n, where n is a positive integer. When we apply basic definition of LT, means Laplace transform, we write Laplace transform of t raised to n is equal to integration from 0 to infinity e raised to minus st t raised to n into dt. Next we have to change this to integration from 0 to infinity t raised to n into e raised to minus st dt. To apply Bernoulli's rule or integrating by parts, we have to change this to this one, means integration from 0 to infinity t raised to n into e raised to minus st into dt. Integrating by parts, we have, as I earlier means here, when we solving this one, e raised to minus infinity t raised to n will not give any constant term. To get differentiation of that constant term is 0. That's why we solved up to 2 terms only here. Now apply integrating by parts rule, means Bernoulli's rule. We get keep t raised to n as it is. Integration of e raised to minus st is to minus st divided by minus s, limits from 0 to infinity, minus integration from 0 to infinity. Now take this term as it is, e raised to minus st divided by minus s. Differentiation of this one is n into t raised to n minus 1 into dt. Differentiate this one, but integrate this one. Integral of this one is keep as it is. Then apply integral to this one. See here, t raised to upper limit is infinity. When we apply upper limit, infinity raised to n, and e raised to minus infinity is 0. 0 into something is 0. Next is lower limit. Here t value is 0. 0 into something is 0. 0 minus 0 will be 0. Therefore 0 plus, here n divided by s is constant. Take outside, minus into minus plus, it will be n divided by s, integration from 0 to infinity, e raised to minus st into t raised to n minus 1 into dt. We can write this as Laplace transform of t raised to n is equal to n by s into Laplace transform of t raised to n minus 1. Why? See here, Laplace transform of t raised to n is integration from 0 to infinity, e raised to minus st into t raised to n into dt. But integration from 0 to infinity, e raised to minus st into t raised to n minus 1. Here t raised to n, here it is t raised to n minus 1. E raised to minus st, e raised to minus st as it is. Limits are as it is. Here it is t raised to n. Laplace transform of t raised to n, when we solve, when we write this to Laplace transform of t raised to n, we get t raised to n. But here integration from 0 to infinity, e raised to minus st, t raised to n minus 1 into dt. Therefore this is Laplace transform of t raised to n minus 1. This integral gives Laplace transform of, basic definition of Laplace transform of t raised to n minus 1. Therefore we can write Laplace transform of, this is Laplace transform of t raised to n is equal to, this is 0 plus, means Laplace transform of t raised to n is equal to n by s into Laplace transform of t raised to n minus 1. Means like this we can write. In the same way we can write further Laplace transform of some elementary function. See here, similarly Laplace transform of t raised to n minus 1 is equal to n minus 1 divided by s into Laplace transform of t raised to n minus 2. Laplace transform of t raised to n can be written as n by s into Laplace transform of t raised to n minus 1. Means it is Laplace transform of t raised to n is equal to n by s into Laplace transform of this preceding term. Here t raised to preceding term of t raised to n is t raised to n minus 1. Similarly, Laplace transform of t raised to n is equal to, here it is n minus 1. n minus 1 divided by s into preceding Laplace transform of this preceding term. Preceding term of t raised to n minus 1 is t raised to n minus 2. Like that, Laplace transform of t raised to n minus 2 is equal to n minus 2 divided by s into Laplace transform of t raised to n minus 3. Also in the same way we can write Laplace transform of t square is equal to 2 by s into Laplace transform of t raised to 1, and Laplace transform of t raised to 1 is equal to 1 by s into Laplace transform of t raised to 0. Next, using all these results, by back substitution, we get, substitute back here, Laplace transform of t raised to n is equal to n by s into n minus 1 divided by s into n minus 2 divided by s, and so on to 2 by s into 1 by s into Laplace transform of t raised to 0. Means we have to substitute back for L of t raised to n. We get n by s into n minus 1 divided by s into n minus 2 divided by s, and so on to 2 by s into 1 by s into Laplace transform of t raised to 0. We know that n into n minus 1, n minus 2 and so on, and is n factorial divided by, this is up to s is up to nth term, therefore n factorial divided by s raised to n into Laplace transform of 1. We know that Laplace transform of 1 is 1 divided by s, therefore Laplace transform of t raised to n is equal to n factorial divided by s raised to n plus 1, where n is a positive integer. These are Laplace transform of some elementary functions, and you have to remember all these results. To remember these results, we have one table here. See this table. Here we have all the 8 results, means Laplace transform of all the 8 elementary functions. First one is Laplace transform of, here f of t is a, means Laplace transform of a is a by s, and Laplace transform of e raised to at is 1 divided by 1 s minus a, and Laplace transform of cos h at is s divided by s square minus a square, and Laplace transform of cos at is s divided by s square plus a square. Then Laplace transform of sin h at is a by s square minus a square. Laplace transform of sin at is a by s square plus a square. Then today's results, Laplace transform of t raised to n is gamma of n plus 1 divided by s raised to n plus 1, and also Laplace transform of t raised to n, where n is running from n is raised from 1, 2, 3 and so on. We use the result n factorial divided by s raised to n plus 1. You have to prepare this table and remember all the results. These results are very important to solve the examples here.